Okay, so I'm going to add videos of me solving questions that I thought were a little tricky in S2. Normally, most questions are just method based. So the few questions that are nice, I'll try to upload videos of those. Okay, so 5A, I'm not too sure which paper this was from, but Narika has a die which is known to be biased, so that the probability of throwing a 6 on any throw is 1 upon 100. She uses an approximating distribution to calculate the probability of obtaining no 6s in 450 throws. Find the percentage error in using the approximating distribution for this calculation. Now, some people were struggling to understand what percentage error really meant, and hopefully by the end of this video, uh, it will be more clear with regards to the question. Right, so first of all, understand that percentage error, to find out error, you have to find out how much your approximate value deviates from the actual value. So you were given a binomial distribution and you want to find out the actual value of probability that x is 0, that if you have 450 throws, you don't get a 6 on any of them, and the probability of that would be, well, 450c, well, this is a little thick. Let me try to, yeah, 450c 0, 1 upon 100, 0, and 99 upon 100 would be 450 minus 0, which is 450. This is all 1, so it would basically be 99 upon 100 power 450, and what should that give you? Which gets you 0.01086, right? So this is basically what this is. This is your true value, or what would actually happen had you not approximated it, right? And that's the value you got by using binomial, because it was given binomial. If you do approximate it to Poisson, however, and you can do so because n is greater than 50, and I believe np is less than 5, don't make the mistake of approximating this into normal. If I'm correct, for that, both np and nq has to be less than 5, and that is not at all the case here. So you're going to approximate this into Poisson distribution, and lambda is np, so you're going to multiply 450 into 1 upon 100, which gives you lambda as 4.5. And now, using this approximation, you'll find the probability that x is equals to 0, which basically would be e power minus 4.5, because baki sab kuch will just cut down to 1 if you put it into the formula. I mean, if you want me to write, then 4.5 power 0 is 1, 0 factorial is 1, so you can just cut this, right? So alpha e power minus 4.5, and this also gives you somewhat value 0.011109. So the idea here is your error is how much your approximate value, again, this is your approximated value, how much your approximated value deviates from the true value. And to figure that out, you just take your approximated value, and you find the difference between that and the true value. So it'll be 0.0111 minus 0.01086. An important note here, if you want to get an accurate answer, which you do want, ensure that you keep these values inside your calculator. So like you have this value inside your calculator, and just calculate this value again when you're subtracting, because if you just start rounding off at this particular step and then you use rounded off values when you're going to give your final answer, especially in a case where the percentage would probably be very small, it would significantly change your percentage because the values here are just so small that you can't afford to round it off. The only place where you should be rounding it off is at the final step. That's where you round it off to three significant figures. Uh, Anyhow, so let me calculate this. So this gives you a value of 2.49 into 10 to the power minus 4. So a very, very small error that you have here. Okay, and again, keep this value inside your calculator. You only want to round it off at the last step. Okay, now the formula for percentage error here, what a lot of science students would already know, maybe it might be something a little less familiar with commerce students, is your absolute error, your error basically, upon your true value into 100. Basically, the idea is how much of the true value does this error make up, right? So your error is 2.49 into 10 to the power minus 4. Your true value was somewhere around 0.01086, and hopefully now you will appreciate why I asked you to keep these values inside your calculator, or to calculate them again. Don't use rounded off figures, because if you do so, you will be using rounded off figures twice, which will lead to error within your own answer, in fact. So let me calculate this, and you'd get 2.29%. Your final answer so you will give this to three significant figures. Yeah, and that's it.